Hello everyone. In this particular video, we are going to discuss about the Titanic exercise. Now let's quickly go through the data that we are having and then let's jump into the solution. Okay. This is the data that we are having where the first column is our passenger ID, followed by we are having survived. This is our output column in which will be having 0 and 1. Okay. And then followed by P class, which means the passenger class. Okay. And then we are having name, what is the name of the passenger, and then we have the column sex, which is representing the gender of the passenger. Okay, it will be having the values male and female, and then followed by age, and in age we are having 22, 38, like that, whatever the age of passenger, followed by this one. This contains the number of siblings and spouses that are traveling with the passenger, and similarly number of parents and children that are traveling with the passenger. And finally we have the ticket number. Okay, if you see, this is the ticket number in the first row and this is the ticket number in the second row, like that. And then we have fare, what is the cost that they have paid in order to get into the ship. And similarly, and then followed by we are having cabin, like in which cabin they were allotted in the Titanic ship. That cabin number was present in this particular column. And similarly, at last we are having embark. In embark we are having three values, that is C, Q and S, each representing some port. Okay, so there are three ports, and in these three ports passengers are coming into the ship. Okay, so these are three different ports and each is represented with C, Q and S. So this is about the data set. Now let's jump into the solution. Before jumping into the solution, I hope you guys have already remembered what are all the steps that we follow in general while developing some solution. We have already understood one solution, that is bike exercise, that is a regression problem, whereas this is a binary classification problem. For binary classification problem, what model we have discussed? We have discussed about logistic regression. So simply we can use the logistic regression over here as well. But directly do we pass all the features that we have to logistic regression? We don't do that, right? First, we'll do some pre-processing. In pre-processing, first can be something like feature selection. Among all the features that are available, you might feel some of the features might not be important. You might remove them, right? Just check the data and let me know in the comment section which are all features that you wanted to remove. Okay, if you don't have some clear idea, once check out the bike exercise and then jump into this video, then you will understand what I'm trying to tell. Okay, so the first step is the feature selection, followed by we might do some feature engineering, in which what we'll do, we'll try to use some two features in order to form some new feature, or from the existing feature you might extract out some other feature. All these things we can do in case of feature engineering. Okay, so this is not the compulsory step. It is based on the data set that we are having. If you feel that some other important information we can extract from the existing two features, that at that time you can use this feature engineering. And similarly, third, we can do something like handling the missing values. First, we need to check whether are there any missing values or not. And if we are having some missing values, then we need to follow some strategy in order to fill all those missing values. And then we can do data encoding. We have discussed various techniques in order to encode, that is either one hot or ordinal or label. These all techniques we have already discussed. And after that, we can do some data scaling. Either it is normalization or standardization. And after doing all these things, then our data set is ready for building some model. After doing these steps, then we need to build the logistic regression model. I hope you guys clearly understood the way in which we approach the solution. Now let's jump into the actual solution. So here we are importing all the libraries and then we are reading our dataset, that is train.csv. So now if you wanted to check the top 5 rows, we can simply use df.head, which will be giving us the top 5 rows. And these are all the columns that are available. like the same data set, this is exactly loaded in the same format. In passenger ID, we'll be having row index that is 1, 2, 3, so on till what a number of rows that we have. And then survived is our main output column, followed by our input features that is P class, name, sex, age, siblings and spouses, parents and children, ticket, fare, cabin, and embarked. Let's check the info, which represents what is the data type of each of these features that we have. And similarly, it will also represent about what are the number of nominal values and what is the number of entries that are available. All these details we can find with the help of df.info, and we can check it. So in age, there are 714 values. And similarly, in cabin, there are 204 nominal values. That means remaining are the missing values. And similarly, in embark, we have 889 number of nominal values. Basically, it will be difficult. We need to minus from 891 to get the exact number of missing values. So in order to find out that, what we can do, we can use df.isnull.sum. So that is what we are doing over here. And by doing this, we'll get the exact number of missing values in each of these columns. Okay, in age column there are 177 number of missing values, and similarly in cabin column we are having 687 number of missing values, and in embarked column there are 2 missing values. Can you guys suggest me some approach in order to fill these missing values in case of age, and similarly in case of cabin, and similarly in case of embarked? I hope you guys have already seen how to fill the missing values. All these details we have seen in the data pre-processing videos. If you haven't checked it out, please check it out. Okay, so you can find out it in the ML playlist. So first check that video, and then like comment down in this particular video what is the value that we need to fill in case of this, and similarly in case of cabin what is the value that we need to fill, and similarly in case of embarked what is the value that we need to fill in the missing values. After commenting down your answer, then only check the video. Now let's jump into this. So first, as usual, we'll do some analysis, and then we'll do all the pre-processing steps. In analysis, as I said, we need to make some questions. The first important question can be, what is the number of passengers who have survived, and what is the number of passengers who have not survived? Okay, so this is the basic question that we can understand from the data, right? Basically, in our data, there are only 2 classes. Simply, this question can be answered with the help of count plot on the data frame, and on x-axis we are keeping the survived. So based on survived, it will split, and there are 500 number of rows which are having survival as 0, and there are almost 300 rows which are having survival as 1. Okay, so this is the count of survival and not surviving. We can also check with respect to like number of male and female, right? How many number of male got survived and how many number of female got survived. So this can be some important question that we can have. So in order to solve that, let's see how we are doing that. First, let's see what is the number of males that are available and what is the number of females that are available. That we can clearly get by using value counts on this particular sex column. So there are 577 number of male, and there are 314 female were there in the ship. And like as I said, if you wanted to clearly understand what is the number of male and female got survived, simply you can use this cross tab, which will work same as the confusion matrix. So here in this axis we are having like female and male, whereas in this axis we are having survived and not survived. So 1 represents survived and 0 represent not survived. Then there are 81 number of female who are not survived, but there are 233 number of female who are survived. And similarly, in case of male, there are 468 number of male who are not survived, and 10 number of male got survived. Question can be clearly answered by this cross tab itself, but some might not be very interested in checking in numbers. Some might be very interested in seeing them visually. For them, you can use some plots like this. Here we are using count plot. On x-axis, we are taking the sex, and hue we are taking it as survived. Basically, just on sex, what it will do, just these numbers will be shown, like how it showed over here. In the same way, for male and female, it will be giving us the count plot. As we have given hue as survived, it will split that based on this survived column. So we have male and female, and in that, as our hue is survived, based on this survived, it will split even further. So there are these many number of male who have not survived, whereas these many number of male who got survived. And similarly, in case of female, these many number of people who got not survived, and similarly, these many number of female got survived. So by seeing this, we can clearly understand that there is higher chance of survival for female because this number is higher when compared to this. And similarly, in this case, there is higher chance of not surviving in case of male. That is what we can clearly observe from this graph. Okay. Even the same we can understand by checking the movie as well. In Titanic movie, also we have seen how hero sacrificed his life for the heroine, right? The same is happening that we can see over here. There are so many jacks over there in the ship that we can understand by seeing the graph. Now let's move on to the other one. Let's see how the P class is affecting the output. Okay. So do you think will P class affect the output? Obviously, right? Let's say if there is a rich guy, he'll be taking the class 1 ticket. And if he's taking class 1 ticket, then obviously they were given the first chance for taking the survival boats, right? So this is what in general happens. Even in the movie, the same thing happened. The heroine's family is very rich, right? All the rich people were going into the survival boats at the starting itself. So this is what happens. So if we see over here, P class 1 people, there are 80 number of people who are not survived. But there are 136 people who got survived. But for P class 2, almost these two are equal, and for P class 3 this is higher than this one. That means clearly we can understand that P class 1 people has higher chance of living. Okay. And similarly we can check the same diagrammatically. This is just the numbers. Some might not be interested in looking into numbers, so let's check the graph. Here also we'll just choose the count plot. X-axis will be taking the P class and hue will be taking it as survived. So P class 1 people, clearly this is lower when compared to this one, and similarly this, almost both are equal, we can say. Whereas here this blue bar is higher than the orange one. That means they have very less chance of survival for class 3 people. Okay, that is what we can understand from this particular graph. And then now let's try to compare which age people survived more and which age people survived less. Here also, if you think crosstab will work, that is not a very good idea. Your crosstab might not work because age is a continuous feature, whereas the features that we have seen till now, that is P class and this particular sex, all these features are discrete features. That's why crosstab might give us good result. But whereas over here, crosstab will not be giving us good result because it is a continuous features and there can be so many possible different values within the age column. Why you will not be able to clearly observe something over here, but whereas over here you can clearly understand that P class 1 has higher chance, whereas in case of this, female has higher chance of living. All those things can be clearly understood just by seeing the crosstab. Here it is not very evident. So now let's move on to the next one, in which we are trying to visualize with the help of some graph. So here we are taking a hist plot. On x-axis we are taking gauge, and hue we are taking it as survive. And bins and multiple equal to stack, this we'll understand. Basically multiple equal to stack, what it will do is, here if you observe, we are not giving multiple equal to stack. That's why these two bars are side by side. If we are giving multiple equal to stack, it will keep one upon another. So this blue one will be kept upon this, or this orange will be upon this, and blue will be under orange one. So like that it will be doing. So here if you observe, it is stacking the blue one above the orange one, and the bins is nothing but how it is dividing this region. Okay, so that is corresponding to bins. Either you can increase or decrease based on what interval you need to check. Okay, and finally this is the graph, and from this graph how we can understand, basically if the orange bar is more than the blue bar, the length of orange bar is more than blue bar, then in those portions there is a higher chance of survival. Like that we can understand by visualizing this graph. So here most of the time in this region orange bar is greater than the blue bar, whereas in this range the blue bar is greater than the orange bar. Okay, so that is what we can observe. That means very less aged people has higher chance of survival. Very less aged people were given the first priority, maybe. Okay, that might have happened. Similarly, there is another way to check this as well. We are separating out the survived passengers and unsurvived passengers and individually plotting based on age. So this is the like plotting with respect to age only on survived passengers, whereas this is the plotting with respect to age on unsurvived passengers. So clearly, if we can observe these individual bars, we can understand who whether this age group, like here this and this are almost same scale, right? So in this age group there are some 12 people who are not survived, but here if you observe in the same age group there are more than 25 or 27 people who got survived. So clearly we can say that in this age group there is high chance of survival. And similarly, if we go over here, this is going till 50. This peak is going till 50, around some 25 or something. So here, if you observe, the peak is going only till 35. The difference is almost 15. So at this age group, there is higher chance of not surviving. Like this, all these things we can clearly understand from this graph. And similarly, if you specifically want some age group of people, if you specifically want to analyze on some age group of people, like let's say some infant passengers or very small kids, you wanted to check whether they survived or not. So we can filter it out. So here we are filtering all the rows where the age is less than 5. Those infant passengers got filtered and kept in this infant passengers, and we are taking out the survival. And on that, we are doing the value counts, which will be giving us what is the number of babies who got survived and what is the number of babies who are not survived. That information it will be giving. But as we are giving normalize equal to true, it will be giving us some kind of a probability score. Okay, so there is a 70% chance that the people who are having age less than 5 will survive, and similarly there is a 30% chance that he'll not survive. Clearly we can understand by observing all these things how age is affecting our output. And then let's see with respect to the family size, how family size is affecting the survival count. Basically within the data set that we have, if you observe, there are two features that are telling about the family size. One is the siblings and spouses, and the other ones are parents and children. So these two are telling us about the family size. So let's see with respect to these two how the output is getting affected. So simply here also we can use either cross tab or we can go with the graphs. So let's see what we are doing over here. So initially we are taking in cross tab with respect to parent, children and survive. So here if you observe for 0, this count is higher than this one. That means that there is higher chance for not surviving in case of 0. And if the parent children count is 1, then there is higher chance of survival because this number is higher than this one. And similarly, if it is 2, you almost we can say that equal chance of surviving and not surviving. Whereas from 3 onwards, there are no significant number of rows in order to make some conclusion. This we can ignore because there are very few people like that. And from those few people, we can make some statement like there is higher chance of not surviving or higher chance of surviving. Like that, we can understand this particular cross tab. Let's see the same with respect to the graph. So here we are placing this on y-axis. That's why these are all bars are on the y-axis, which are horizontal, whereas previously we used to do the same on x-axis. So all these bars are vertical, and if you want the bars to be horizontal, you can use y-axis. And here also we are giving multiple equal to stack, so these bars are one upon another. Here also we can clearly understand that here this orange one is slightly on lesser side when compared to blue, but in case of 1, this orange bar is higher than the blue one. In case of 2, almost both are equal. In remaining cases, as the number is not higher, there is no point in checking all of this. And similarly, if we observe the same with respect to siblings and spouses, here also almost we are observing the same behavior. Okay, so here when it is 0, this count is higher, that is more chance of not surviving, whereas 1 has higher chance of surviving, whereas 2 almost equal, and remaining cases are not that significant. Here 3 and 4 have some significant number of rows. By observing this, there is clearly higher chance of not surviving. Same we can observe with respect to the graph. Like that, we can analyze our data that we are having, and let's see how embarked is affecting our output that is survived. Okay, so what is our embarked? Embarked is telling about the port in which they came into the ship. So on x-axis we are taking the embarked, and here we are taking it as survived. So S, C, Q, these are the three ports that we are having. And in these ports, how we can understand? We can understand if this light red bar is higher, that means that there is higher chance of not surviving. And if the dark red bar is higher, that means there is more chance of surviving. The people who came from C has higher chance of survival. Maybe we can't say directly that coming from this port is affecting the output. Maybe the other reasons, like in this port there might be people who are rich. Okay, obviously rich people can give money and do something so that they'll get the survival boat first. Like that, they have the higher chance of surviving. So like that, we can analyze indirectly also some features will contribute to the output, right? You can think this is such indirect feature which is contributing to the output. Here, by seeing this graph, we can understand that the people who came in the seaport has higher chance of survival. Like that, we can make some plots and we can understand about the data that we are having. And here, let's try to understand how our fare is affecting the output column. Okay, so here also first we are dividing it into two parts. One is all the survived passengers will be there in this survived DF, and all the unsurvived passengers will be there in the unsurvived DF. After that, we are plotting individually. We are making his plot on the survived DF and unsurvived DF. Now let's observe the graph. So here, if we check the survived passengers, like the guys who are paying very less, the survival count is near to 160. But here, at the same region, if we observe the unsurvivable count, it is more than 300. So the people who paid very less, there is a very less chance of survival. That we can clearly understand from this graph. And similarly, here if you observe, this graph is going till 500, but whereas this graph is going only till 250. That represents that all the people who paid more than 250 are surviving. Okay, so all these conclusions we can make by observing these graphs. Till now, we tried understanding about the data that we have. We made some conclusions by observing all these graphs. Now let's do some pre-processing. As I said, the first thing that we will do is feature selection. It is not a necessity, but it will be good if we can remove some of the features which are not related to the output that we are having. So here, this survived will not be affected by passenger ID. That is very obvious, right? Because it is very unique number, so that's why it will not affect the output that we are having. And similarly, if you observe ticket number is also a very obvious thing, which is unique for each and every passenger, right? So that's why this will not affect the survived count that we are having. And then any other column apart from this passenger ID and ticket, if we carefully observe, there is name as well. Name doesn't affect the output, right? So let's say there is a guy with name some Santosh. So if as he is having the name Santosh, he will have a higher chance of survival, and the other guy name is Suresh, let's say, and Suresh will have lesser chance of survival. It doesn't happen like that, right? So name will also not affect the survived column. These three things we can directly remove, that is passenger ID, name, and then ticket. Okay. And also, if we carefully observe, we can remove this cabin column as well. That is because if we observe the number of missing values count, in cabin there are 687 number of missing values. and the total number of rows that are available for us in the dataset is 891, which is more than half number of values are missing over here. In that case, it is better to remove the column itself. Instead of making some assumption and filling out the values, it is better in order to remove the total column itself. So that is what we'll try to do. Finally, we'll be removing this passenger ID and then name and then ticket and also the cabin. Okay, so these all columns we'll remove. Let's see how we are doing that. We are dropping the passenger ID and we are keeping in place equal to true, which means which will do this operation in place. And similarly, it will remove the cabin column and then ticket column and then name column. So all the discussed columns were removed, and then we are left with these columns. This is our output column and all these were input columns. And obviously we need to fill the missing values. In age column there are some missing values, and in embarked column there are some missing values. So let's try to fill out these values. In age, what strategy can we use? The simplest strategy can be something like mean, and in embarked the simple strategy can be mode. Okay, so now let's see what we are trying to do over here. So here we are finding out the mean of the age column, and then we are also finding out the standard deviation, and then we are filling out the values. So here, let me explain you what we are trying to do. So basically, for the age column, we are finding out the mean, and also we are finding out the standard deviation, and then we are fixing some range, like that is mean minus standard deviation to mean plus standard deviation, and within this range we are generating some random numbers and then filling the missing values. There are 177 number of missing values in age column. Instead of filling all of these 177 values with mean, it is better if we can fill all these values with some different values, right? And all these different values should be within some range so that it will not be very random. Okay, so that's why it is a really good strategy in order to take some random number from mean minus standard deviation to mean plus standard deviation. We are taking within some very small range from mean. So let's say mean minus 5 and mean plus 5. Within this range, we are trying to generate all the numbers and we are filling out all these missing values. So this is better strategy than filling all of them with mean. Okay, that is what we are trying to do over here. We are finding out the mean, and then we are finding out the standard deviation, and then we are finding out the total number of missing values in the age column. And finally, we are generating some random integers within this range, and we are filling uh, all the places where it is missing. So it will select all the rows where the age column is missing, and it is filling it with this particular random age. And similarly, in embark column, simply we are using mode in order to fill the missing values. In embark column, there are no many missing values, so mode will work good. Yeah, in embark column, there are only two missing values, so mode will perfectly work. We are done with feature selection. We are done with handling the missing values. Now, if you observe, in this age column, there are no missing values, and similarly in embarked column also, there are no missing values. Now, let's do some encoding. In this, sex and embark need to be encoded. So we take those columns, and first what we are doing, we are applying some label encoding. What label encoding will do? Label encoding will randomly give some numbers, right? So in case of sex, there are male and female. So it will be assigning randomly. For male, it can assign 1 and female 0, or it can do it in reverse. Whereas in case of embark, there are three values. So for S, it can assign 0, and for C, it can assign 1, and Q, it can assign 2, like that. Okay. First, initially, we are doing it random, but random is not good all the time. We might go for one hot encoding. That is a little bit better. So in order to do that, basically, like we have P class also, which is having three distinct values, and the encoding that we are seeing might not be correct because P class 1 has higher chance of survival, but in P class 2 and 3, we are not very sure who are having more chance of survival or who are having less chance of survival. Or if you are comfortable with this 1, 2, 3, or if you think that this is good enough, then there is no need of applying it on P class. Directly, we can only apply it on embarked. In this X column, there are only two values, so label encoding will work good. In embarked, this 0 and 2 might be jumbled, so we are applying this one hot encoding on P class and embarked, and we are mentioning drop first equal to true. So that's why in case of P class, there are two separate columns available, and similarly in case of embarked, we have two columns. Okay, so now we are left with all of these columns, and the final thing that we can do is we can do some scaling. So before going on to scaling, we can also do feature selection with the help of this heat map. What heat map will be giving us? This heat map will be telling about the highly correlated features, and we can remove one of them. Like let's say if two features are highly correlated, in this case we can say that like this siblings and spouses and parents and children are somewhat highly correlated. So among these two, we can place only one, okay, instead of keeping two. So this we can do when you feel that training time is more. Basically, if we have more number of features, then it needs to adjust those many number of parameters, right? So the training time will increase little bit. If you wanted to reduce that training time, then you can go for this. If you are okay with it, then you can just simply move forward. So in this case, we are not doing anything. We are just checking the correlation matrix, and then we are leaving everything as it is. And then finally, we are doing some min-max scaling. Okay, we are taking all our columns, and finally we are applying our min-max scaler, which will make everything into the range of 0 to 1. And finally, this is our data frame that we are left with. So in X, we are keeping all our input columns, that is all these columns apart from survived. And similarly in Y, we are keeping only our output column, that is survived. Okay. And finally, we are doing the train test split. Like this process is same every time. So we are mentioning testing size to be 0.25, which means 25% of the points will be going into the testing data set, whereas remaining 75% will be going into the training data set. And then finally, we are adjusting the logistic regression. And then we are passing this logistic regression model to grid search CV. We will understand about this in the next video. But for now, just think that we are simply applying logistic regression, and then we are fitting on the training data that we are having. Okay. So while doing this fitting, all of the training process that we have discussed will happen over here. And finally, after all that training, like the score that we are getting is 80 on the training data, and similarly on the testing data we are getting 77, which is quite good. So this is the accuracy that we are having. So we can say it is okay kind of model. And if you wanted to predict on some testing data or any new point, simply you can pass grid search dot predict, and you can pass the data point that you are having. It will be giving us the result. So here, as we are passing X test, it will be giving answer for all the testing data points. So these are all the predicted values for the testing data that we are having. So in the next video, we are going to discuss about this particular grid search, what is happening over here. I hope everything that I have explained in this video is clear for everyone. If you have any doubts, please comment down in the comment section. Thank you everyone. Bye bye.